So, welcome. My name is Alessandro Savino. I'm going to present you the career on embedded system. The presentation will be in English until the end, then questions can be either in Italian or in English. That's not a problem. So, let me start with what an embedded system is, because most of the time the question is, okay, but why in computer science we're talking about embedded system, not systems in general? Well, I would say that almost everything you can touch today or you can see up in the sky is an embedded system. In the sense that if you exclude cloud computing, HPC, and this kind of special stuff, including the desktop that you can have at home for doing your homework, play something, even video games can be considered an embedded system. Because it's a system that is designed for a purpose and where everything, from the hardware that is inside and the software that is controlling, is tailored for that purpose. Why this is important? Because as you will see, this is going to reflect to the jobs, to the kind of opportunity that you might have with this kind of career behind you. What are the objectives in the career? Well, we basically cover from a high-level hardware part up to the software, in the sense that the idea is being able to understand and design system on chips, where clearly you don't care about the manufacturing here. That is not part of what we're going to give you back as information, while some basic information about manufacturing, as you will see in the set of lectures, it would be hidden here and there. Then, on top of that, what is expected to be taught is how to customize your system for your need. And this involves many things nowadays, because it means computational efforts, first of all, but also security, safety. All these parts are counted together. Then, of course, security and safety, they depend on the kind of goal, the target of your system. But let's say if you're sending a satellite today or you're building a vehicle, security and safety, they are part of the deal. Maybe in a console, the security part is a little bit limited, but probably not totally absent at all, I mean. And also there, the safety, it's probably limited, but it's still there. On top of that, of course, you need to control the hardware, we said. So you can expect to know how to control the hardware in two fashions, basically. Bare metal, this means firmware, and everything around, and operating system-wise. When we're talking operating system-wise here, we talk about general concept on operating system, but also very tailored operating systems such as real-time one, where the constraints are a little bit different, the way they carry the tasks, it's more tailored to be, as I said, real-time. On top of that, an operating system requires application. Nowadays, embedded systems are not just console-wise system. They include also a bit of user interface. Nowadays, the user interface is coming very close to the user interface of any other general purpose system. So this is going to be part of what you're going to learn, and eventually a huge part, I would say, of the plan is also giving you information about all the other aspects of your optimization of the system, that it's not only the computational efforts or the security and the safety, but also the power management, so the energy save in general, and I would say going down into IoT stuff, which are probably the most demanding in terms of low power. So some of the characteristics that we believe are important to show you, so that you will remember after the presentation, okay, this kind of career is giving me this stuff. Well, first of all, it's taught in English, so all the teaching activities, also the optional ones, at least with what we suggest, everything is going to be in English. Nowadays, and clearly I'm here to change a little bit to convince you to enroll in this career. So the number of students nowadays, it's kind of small, around 40, 50, more or less. This is good. Clearly, I want to improve it. This is why I'm here. But the idea is that with such numbers, in general, let's say below 100 of students, you can expect also to interact with the teachers in a more direct manner, and probably but this is also up to you, of course, in the classroom to interact a little bit more, to be less passive in taking the lecture and try to ask questions, clarify things, but also, and this is part of the deal of also being smaller, you can expect a strong focus on the experimental activities. Most of the current lectures, they focus on general and theoretical approaches, but also they try to deliver labs, projects, things that you can use to improve a lot your skills, okay? And I believe this is a plus. Together with the teaching activities, there are possibilities. Some of them, of course, are common toward the full spectrum of computer science, but especially for embedded system, I would say, and I will mention something also later, most of the teachers involved in the path, they have a relationship with companies, with other universities, so you can expect to have a close connection there. Some of them, and they asked me to deliver this message, and I believe it's important, even in lectures, they attract researchers or engineers from companies to tell you something about the topic, okay? So assistance and power management for IoT stuff, you can expect that at a certain point, maybe for some lecture, someone will tell you something on a real job activity, or the same thing for the SoC, so the system on chip design. This is what you can expect. Then clearly, this wide spectrum of collaboration reflects also in the Erasmus. So as any other path, you can go and spend some time abroad. And among the embedded system, there is also, like for others, the opportunity for double degrees. Okay, so if you're interested in having double degrees or experiences in learning also outside the Polytechnic, this is part of the deal here. What are the skills? So kind of a list of skills that you can expect at the end. Some of them are generic enough, but others are very specific, as you can see. That would be a bit of basic of electronic, even if the computer science embedded system path clearly goes into hardware-software interaction. This is the big focus there, and the design. But clearly you need to know something about electronics, because at the end, whatever you're going to build up, you know what it is inside somehow, okay? Then, to do that, you will be taught specific languages that help you nowadays to describe the system that you want at the end, so the hardware part, I mean, like a software, from a functional perspective, first of all. Then you need to add some details, but the idea is you don't look at just small signals and connect together in a crazy way. You have a general and very structured form for describe your system. Then, of course, you will need, and that will be provided, more information about computer architecture, advanced information about computer architectures, because a computer is not just a von Neumann machine anymore, it's something far more complex, and this is part of the deal here. In terms of programming skills, on top of operating system, you're going to basically program in Python and C/C++. These are going to be the main languages for delivering your final programming task. But as I was saying, also modern UI approaches are coming into the field, so you can expect also to expand a little bit and maybe play a little bit with JavaScript and similar stuff. And then the extra information that for many of you probably are very new, but those are going to be skill and pillars at the end. They will be, you will know how to debug the system, not just in terms of, I wrote a function and I need to debug the function to find if I program it properly, but also how to debug the system and how to test that the full system, the hardware and the software are working, are exactly what you wanted to achieve in many terms, functional, but not only functional. And also, on top of everything, if you want to plug safety and cybersecurity, you need to know how to do that, what it means, what are the concepts there, but also the technical aspect. And in the end, some of the job, as you will see, are going also still in that direction. You need to know something about software management, because an embedded system, it's still a big project, and so you need information on how to deal it in a proper way, in the sense of a very effective way. Going to the teaching plan, so that I can give you a little bit of perspective of what you can foresee for the first year now, and then in the next slide, the second year. Well, in the first year, as you can see, the first semester will be kind of a 0 point of all the fundamental big information that you need. So there will be computer architectures, there will be operating system, and as you can see from the title already, operating system means not just a general concept on operating system, but embedded system tailored one, so that they are going to be realistic. That would be the fundamentals of electronics for this kind of system, and how to simulate them, because at the end, most of the time, especially the design comes very early in the stage, and when you have the final board and everything to touch and see if it's really working, the time lapse is pretty big. So you usually start with simulating your system at the maximum capabilities that you have, and this is something that the first semester will cover. While in the second one, you are going to, let's say, complete the electronic part, in the sense that there will be the microelectronic system lectures that are going to complete the basic fundamentals knowledge about the electronic that you need here. And you will have the software engineering, synthesis and optimization that would tell you, once you design something, as I was saying, in a very high manner, or I would say also intermediate in some cases, how that thing can at the end be the final mask that the foundry will build as a chip or a board more in general. And you will find a little bit of lectures about cybersecurity. That cybersecurity is not going to be a general one, like let's talk about cryptography. No, that thing is tailored again on embedded systems. So not only existence, how the cybersecurity that you will know at that point can be played inside an embedded system where sometimes resources are small. So if you want to go existent post-quantum cryptography, that would be kind of a challenge. But also more physical things like attacks on the systems, like Rowhammer and similars, the concept of root of trust, everything about the cybersecurity that you need in here. And then in the second year, as you can see, you have a little bit more room, in the sense that the first semester is still pretty packed, but as you can see, you still have 4 courses there. Some of them are going to go extra with the thing that so far probably you never seen. So the energy management part, that would be tailored for IoT, because as I was saying, it's the most challenging aspect here in embedded system, but clearly the concept there, this is just a label, the concepts are applicable for any embedded system as soon as you want to deliver some proper energy management. That would be the system on chip architecture. So once you have the small thing, but you want to build everything down into a single chip, which is actually the reality for most of the system nowadays, where inside a single stuff you have the microprocessor, the memory, the GPU, and all the other peripherals that you like. And as I was saying at the beginning in the skills, also how to test. And when testing, we are also considering faults, so the possibility that the system has, permanent or not, this is not really important there, because you will cover everything, an error due to a fault in your system. And as you can expect, most of the embedded system that you may recall from the very beginning, especially in a satellite, as I used to say during the lectures, when a satellite breaks down, nobody can go there and repair. And the life expectation of a satellite can be 40 years, 50 years, 30 when you are lucky, in the sense that you don't need to cover too many years. And probably whoever built the satellite in the first place, at the end of his lifetime, is not going to work anymore too. Okay, so you have to expect that those systems there, they don't go like your normal computer. They have to go there with some fault tolerance, with something that makes possible when an error arises to resist that error and still keep the mission going on. Okay, so this is the kind of idea there. And in the second semester, basically, you will have still some possibility of personalizing your path. And I will tell you what we suggest, which is just a suggestion, so you will keep it as it is. And carry the final project and eventually a challenge if you like. In terms of suggestion, there are, as you can check on the tables, many options I know that the colors somehow are not very good in the projection here, but in any case, we can talk about that later. We suggest a couple of options. As you can see, they overlap in the sense that you can have some of them placed either in the first semester or the second one, while some others are not offered in the second semester or in the first one. So if you want to follow them, you need to put them exactly there. And if you look closely, they basically allows you to personalize your path in basically two ways. Augmenting the peripherals, the working peripherals, the functional peripherals that you may want to tackle in your system. GPU is exactly the perfect example. So almost no embedded system right now are without a GPU, okay? Because they can carry artificial intelligence operation as well as graphical operation, so you probably need them there. And you can also specialize a little bit in the IoT, so in the compartment of embedded system that is more demanding, as I was saying before, okay? As well as, and this is the first in the list on top of them, also specialized in AI, machine learning, but in the embedded system, so where the resources, the timing, everything that cannot be a large language model there should be something smaller, okay? And you need a preparation for that. You don't, wake up with a LLM at your disposal and the next day waking up you say, okay, I will put in an embedded system for IoT. Okay, this is not the way it goes. Maybe you can do that, but you need a little bit of work, you need an approach, a methodology, and so forth. So, motivations, because maybe I was not clear enough. I try to give you also some motivation. Well, as you can see, the salary is kind of in the range, okay? I try to make some researches for this presentation, as last year I was not very well prepared on the money. Maybe you're not here for the money, but let's say that the compartment, this is a salary extracted for Italy, so I didn't work, worldwide. For Italy, this is the kind of expectation in the actual open position that you can search online, basically, okay? It can be enough for you, it cannot be, I don't know, but this is kind of what the actual search can give you. But especially where you can expect to go working into, of course, if your interest will be into moving directly into work instead of research, because then we will talk about research too. Basically, automotive, space, avionics, railways, industry 4.0 now, it's really crazy about embedded system specialists because, they can build embedded system for checking manufacturing issues and prevent selling a product with some defects and all this kind of stuff, playing with the machine learning too, but that's the kind of deal that you can have here in terms of job opportunities. And what are going to be the job? So what are going to be the, let's say, the keyword for the job position? They're very general, but also I did some research and I report here the general labels on top of the jobs in my search were also providing the money that was in the previous slide. Basically, you can be an embedded system engineer, software engineer, sorry, which means that you will need to be specialized in delivering the software, so the applications, but in an embedded fashion. So you can expect there not just to open your computer and start programming any user interface as you like, but maybe checking first the resources, the power consumption, the timing required for the interaction, and then on top of those numbers, definitions, go for the implementation. Or you can be a firmware engineer. Most of the embedded system, they don't have an operating system at all. They have a kind of a bare metal implementation where they may call operating system something that it's actually scheduling a couple of tasks, but in a very fixed manner, because they just circulate, or it's even more simple. It's just a very small part of an operating system that is starting up everything, opening the course, placing the several tasks on top of the course, and nothing else, okay? And you need to be an expert in that thing, so you need to know how to handle this part. Or you can be an embedded system architect, which means that instead of writing software, instead of writing hardware alone, you're going first of all to design everything. So someone, your boss or some company, will come to you and you will be responsible, or part or a team responsible of course, of getting all the information that they want, with the kind of mission of the system, if they have even money very limited or not, and on top of that, knowing the hardware, knowing the software interaction with the hardware, and the software generate the full system. Okay, and last thing, which is important because they pay quite well, because the experts there are not a lot, test engineer. Which means that instead of writing software, instead of writing firmware or operating system, instead of designing the hardware, you get everything at the end and you test it. Okay? This looks maybe not very interesting now. Trust me, when you put everything together, the information that you need and the money they can give you, this kind of change your perspective there. Okay? In all of them, but this is mandatory, and I expect everybody here can tell the same for all the other paths in the end, you can see a career there, clearly. So you start maybe part of a team, and there could be team leading and something else on top of that. But this is not what we can ensure, of course. We just prepare you to be able to handle them. Final words about a couple of things that I believe they are important here, and then I let you ask any question that you want. Well, first of all, the department. As any other career, there is a department behind, and the department is kind of a guarantee. Why? In my opinion, but I'm part of the department, so kind of in a strange position here to say so, but we have a PhD program, first of all, which is a very good one. Very well scored. So if at the end of everything you end up, let's say during the master thesis, with the curiosity of trying a PhD, so to enrich even further your skills and what you can learn, there you will find teachers, tutors in that case is the perfect wording, and positions. It's a very active department, so the number of positions are very incremental year after year, and we cover not only PhD in loco, but also national-wide PhDs, so the opportunity will be a lot, and I believe they will still be a lot in the next years. And as I was saying, but this applies also for the full department, we have a lot of collaboration. As Gabriella was saying for the previous career, this applies also here. This collaboration includes companies, but also research centers, so other university or research centers alone. Okay. Another thing that is very important, and we are growing there, so I believe this is an important message for you. We are growing in the collaboration in national and European projects, so you can expect there to have opportunity for moving within the PhD to go around the world also for this reason. And as I was saying, the embedded system is kind of a very attractive field, so this is going to grow a lot. In terms of industry collaboration, of course, I'm not citing one by one everything there, because it will be also publicity here, but the point is, this is a kind of a collection that one of my predecessors started, and I try to keep updated year after year of the collaboration that we had, we still have, or we will have in some case, because there is someone working on contracts for those kind of stuff. And those industrial collaboration, you can feel they are going to come into the career already, because all the projects at a certain point, they may grasp from there some concept that is going to move into the teaching, and you can apply on top of that and try something. And the same goes for the university. This is, again, a non-comprehensive list. Probably I'm missing someone or something, but this is the kind of collaboration network that all the groups that are working in embedded system topics in general, they can offer. They come, as I was saying, from European projects, they come from direct collaboration. Most of the time, those are clearly research collaborations in the case of university, but as you can see, they cover Europe, but not only Europe, okay? And I believe this is something that you have to consider, okay? So this was all. I hope it was not too quick for you, that I gave you all the information that you want, and now if you have any question, I'm here exactly for this purpose. Thank you.
Ok, avrei un paio di domande. La prima è che nel secondo anno, nel piano di studi, mi sembra ci sia la scelta se poter fare challenge da 8 crediti oppure il credito libero da 6. Questo divario di 2 crediti viene recuperato in qualche modo oppure non so adesso il funzionamento?
I translate the question first. So the question was for the non-Italian guys. As you can see here in the table, there is a choice between a challenge and a free set of credits. And as you can see, the numbers are different. And then the question is exactly how they compensate.
They are 2 extra credits. So it means that in that case, you achieve 122 credits. So only 6 credits are curricular credits and the other 2 are extra. So if you decide to take the challenge, and it is one option that you have, in that case you are doing 2 more credits.
Okay.
And learning something still.
Yeah.
I'll try to phrase the second question in English.
As you wish, no problem.
Given the electronics basics that this course requires, do you think that the preparation that the 3-year course of computer engineering that Politecnico gives, the electronic preparation, is enough to take the course, or is it too much? Maybe because there's this debate where we do too much electronics in 3 years, and I was curious to understand if it's too much, if it's really needed, the things that we are learning, or is it really enough? Yeah.
Okay, so let me try to check if I got the question.
Yeah.
So you're wondering if the electronics, the amount of electronics that you are learning now,
Yeah.
before enrolling, is too much for the path. Did I got it right?
Something like that, yeah.
Okay. That's a kind of an interesting question. It's the first time that someone asks something like that here, I guess at least in my knowledge. I would give a personal answer. There is never a problem of knowing more, okay? In the sense that, especially if you think on the special lectures here, so the testing and fault tolerance, the energy management thing, they clearly try to stay and sit well inside the curricula, okay? So you can expect to have all the basis for understanding everything. But then, after the lectures, there will be the real world. And there, it can happen that the information that you have here, they're just the basic ground for something a little bit more complex. In there, knowing more about electronic will still be kind of a good thing to have in your skill.
Okay, thank you.
No problem. Yeah.
Hello. What does the challenge consist of?
Well, that depends. Year after year, there is Assistance 1 in cybersecurity. That is the one that I recall. Do you recall any other specific challenges?
No, usually challenges are proposed by companies. There are 2 different types of challenges. By firm, and they are proposed by a company, or by students. In the second case is a research group of Politecnico that proposed the challenge. But usually the challenges are proposed by companies. In that case, you have to solve a problem proposed by the company. So the company proposes you the problem, then you are split in groups. You are groups of 4 or 5 people usually. And each group try to solve the assigned problem from a different facet. So you have to propose an innovative solution for the problem that is proposed by the company. This is the goal. And usually in each challenge, there are students from different master degrees. So there are students from computer engineering, from data science and engineering, management engineering, civil engineering. So all the master students, or the majority of the master students, can enroll in the challenge. For each challenge, there is also a list of recommended master degree, but theoretically, everybody can apply for the challenge and can be selected for the challenge.
And another question I have is, you said that one of the potential outcomes of the degree is architect, engineering, embedded systems architect.
Yes.
Will we have the chance to design chips and fabricate them in the Polytechnical, and also PCBs, printed circuit boards, or is it just theoretical in that sense?
No, it's not theoretical, but the manufacturing process, as far as I remember, is not covered by the system-on-chip design lectures, but you will expect to go basically down to the mask, and the manufacturing process would be out of the scope, also because it has time, first of all, and money requirements. But the tools that they are using, the practical examples, those are real things.
So it would be like Cadence and...
Yeah, exactly, those tools.
And PCBs, printed circuit boards?
The same. The lectures are going to focus on system on chip because it's the most complex design there. And PCBs, as far as I recall, is not directly covered. But let's say the manufacturing there will have the same issue. That you need time and a lot of, especially a lot of up and going before the manufacturer says, okay, I go there and I print the PCB, or I manufacture a system on chip. What you can expect is to have some of this experience eventually in the master thesis. We have connected already there, public now, then for you maybe it's too early, master theses that are going in those directions.
Alessandro mentioned the thesis, but you have also the opportunity during the internship. In this case, internship and thesis are usually connected together, so you have 12 credits for the internship and 18 for the thesis. We suggest to do both in the same company, but potentially you can also do only the internship, 12 credits, and then the thesis in a different location. Okay.
Sorry. In the embedded software engineer, is there any courses or lectures that spend some times about the communication protocols and these stuffs? I mean, is there any courses that teach us in these stuffs or something like that?
You mean communication protocols and similar?
Programming or UART, USART, this one of.
What do you mean by communication programming?
No, communication protocol.
Yeah, but the programming part, what do you mean about that?
I mean working with Mac controllers for, how to say that, using...
Yeah, these two courses here, the electronic for embedded system and the microelectronics, they will set up most of the time system on chip from a high level perspective. So there you will also see for sure protocols for communication inside the system especially. Okay.
So these two staff focus on the communication protocol?
They don't focus exactly only on those things, but they include them in the path.
Thank you so much.
No problem.
You have also the opportunity to personalize your study plan using the free credits. So if there is a course that you are interested in offered by another master degree, you can ask to substitute one of the free HTS courses or even both. If you have a motivation for doing that, your request is accepted. Okay? So you have some degree of freedoms to personalize your study plan.
Well, in any case, you can reach out. My email is public, so if you have any further question in the upcoming weeks, months, you can send them. I'll try to answer as soon as possible. give me some time, but I will do.
Thank you, Alessandro.
Thanks to you.